Term. We didn't talk about a term, but you talk about like terms. You talked about what an algebraic expression was in your group. Who knows if you're right? Who knows if you're wrong? This is what an expression looks like. Oops. I'm gonna do that. That's an expression. An expression is a math sentence. It's got letters and numbers in it. Maybe that's what you said in your group. I don't know. Maybe your guess is right. Maybe your guess is wrong. Who cares? You just want to keep writing and keep writing, and we can talk about it when you're done. That would be the easiest thing to do. All right, so algebraic expression has letters, variables, and operations in it. So this would be an expression. I don't know what you said in your group, but that's what an expression is. Okay, it's basically just a math sentence. Coefficient, this is another word I asked you. A coefficient is the number with the letter. Okay, so the number with the letter. So up here, coefficient would be 2. What's my other coefficient? Brooklyn? 2x or x. No, x is never in the coefficients. It's never in the coefficients. It's always the number. What's the other number up here that's not really there? What can I put with a lonely variable? Logan? A 1. So in this one right here, the coefficient is 2 and the number 1. Don't forget the 1. Remember I said yesterday, from now on you have to put a number or a lonely 1 with a lonely variable. Comes true today, tomorrow, and the next day. So always do that. And you don't include the x with the coefficient either. That's something that so many kids screw up. They forget that they don't need that x, so you don't need it. Constant, that's a number that's always going to be there without a term. So in this case, it's 8 and 3. Okay? 8 and 3 are the constants. They're never going to change. Okay? Any questions so far? Any questions so far? Okay, what I want to do first is I'm going to make a expression. So okay, so in here, tell me the terms. What are the terms? Now, if you remember from last year I had you take a pen and I had you basically circle all the terms. Does anybody remember doing that? Remember we did that? Okay. Terms also include the sign in front as well. So here, what would all the terms be? What would the terms be? We're just going to list them, like if we broke this thing apart, what would the terms be, Aiden? 4x. What's another one? You're right, -3 is another one. Good job. That's why that sign up has to go with it, because that all of a sudden, when we break it apart, it becomes like a -3. What else? What's another one? McKenna. 3x. Very good. What's another one? 7. Those are my terms. Good job. Okay. What are my coefficients up here? Somebody I haven't heard from yet. What are my coefficients up here? It's okay to be wrong. Logan. The 3 and what else? One other one up here, Tyler. Not the -3. You're close. Aiden? 4. Coefficients are the numbers with the variable. Good. What's my constant up here now? Something without a variable. What's a constant? Now what, Tyler? You said it before. Yep, that's a constant. What's my other constant up here then, Hannah? Good. You're going to have to do this in your homework today. Any questions so far? Okay, let's go to my next vocabulary word. I asked you what a like term was. What do you think a like term is now? What do you think a like term is? Talk about it with your partner if you don't want to talk to me. Talk about it with your partner. What's a like term? If you had to look up at this, what would like terms be up here? Talk about it with your partner. Okay. Okay, so what do you think? I don't care if you're wrong or not. Tell me what the like terms are up here, Brooklyn.
-3 and 3.
Okay. Nope, good try. Good try. Thank you for answering. Thank you for answering. What do you got? What do you think? Logan, try it again.
So 4x and 3x.
4x and 3x. You are right. This is a like term. This is a like term. Why are they like? Aiden?
Because they share the same.
Yeah, they share the same variable. There's another set of like terms up here. What are they? Somebody I've heard from you today. Sorry. Jake. Yep, these are like terms. What can you do with like terms? What can you do with them? Kate?
Add.
Yes, you can put them together. You are right. Definition of like terms. Terms that have the same variable or exponent. We're not going to deal with exponents today. So like terms, terms that have the same variable. Or they can be constants too. Can be constants. Because you can also put those together. And honestly, you don't even need to write this. I'll just talk about it. You don't need to write the simplifying one. Just write the top. So like terms, the terms have the same variable and exponent, and they can also be constants. We're not really going to talk about exponents today, so worry about the variables right now. Now, those like terms, you can combine them. That's what this means, simplifying. You can put them together to make it as small as possible. Remember yesterday when we did distributed property, we made it as small as we possibly could. We took out the parentheses. We got rid of them. That's what we're doing today. We're making everything as small as possible. So can I go back to the next slide? Can I go back? Maybe we still need this? Okay, I'm going to go back here. Let's look at this. I'm going to rewrite it so we can see a little better. So it's 4x minus 3 plus 3x plus 7. Now, you told me the like terms. I'm just going to circle these like terms in green. Okay. And I'm going to do these in blue. So let's talk about these terms. Let's put them together. This is 4x. And since this is in front of the 3, it says plus 3x. So how many x's am I going to have all together now? Kate?
7.
Yep, 7. Okay? 7 x's. Now let's talk about my 2's, or my blues, I guess. This says -3. I got to keep that as negative. Plus 7. What's -3 plus 7 here, Aiden? Positive 4, right? Because we have to remember what kind of number that is, because that's going to tell me what sign is going to go here. So if that's a positive 4, it's going to be a plus 4. This is that simplified, as much as I can simplify. I can't go any further. I don't know what this is. Okay, so do you kind of remember this a little bit from last year? If you want to use colors and circles and lines, I don't care what you do on your paper, as long as you can understand. Because I kind of like to see like what I'm doing. Sometimes you might have to write things out. So we'll do that if we need to do that. Let's practice this a little more. Okay, always put a 1 in front, identify, we already know how to do that stuff. Okay, let's do some simplifying. We'll do some easy simplifying to start with. Easy simplifying to start with. I have 8n plus 4n plus 4n. Okay? So what are the like terms up here? What are my like terms, Aiden? Yes, 8n and 4n plus 4n. So how many n's do I got up here then? Aiden, you can go ahead. You bet. 12 n's. So I have any other things that I can put together? What do I got left over then? Got plus 4. So he would just kind of tag along at the end, plus 4. He doesn't get out of anything else, there's no other constants to add him to, so he's by himself. Okay. Let's try the harder one. This is not very hard. We're going to come back to those. We're going to come back to that. All right, let's try this. 6x plus 7 minus 2x plus 3. Try that one yourself. If you need to circle them so you know what signs they are, great. If you want to use 2 different colors, great. I do not care. I do not care. If you want to check it with your partner, check it with your partner. I do not mind. All right. Anybody share? Share with me? Somebody I haven't heard from yet today? Haven't heard from this group? Haven't heard from, I've heard from everybody else's group. What do you got, Dylan?
4x plus 10.
Okay, so put these two together, so 4x plus 10. Perfect. 4x plus 10. Good job. Feeling okay? Let's try one trickier one. Okay? Because if I'm adding some more negatives into it, I want to make sure that we can get it. So negative 5x minus 3 plus 7x minus 4. This is going to be a trickier one. You might want to talk to your partner about this one. You might want to circle the like terms and rewrite some things out for yourself. It's okay to do that. It's okay to do that. Talk to your partner if you want to talk to your partner. It's fine with me. Why was this one a little trickier? There's a lot of negatives in there. A lot of negatives in there, or subtracting, or whatever you want to call it. Anybody want to try it? Anybody want to try it and see if they can do it? I think I remember this last year. Remember you guys were like, give us a harder one. Give us a harder one. We did it on marker boards. Give us a harder one. I think we ended up with like how many different terms on here. Do you guys remember that? Give us a harder one. Maybe that was only one of my classes. I don't know. Dylan, you want to try?
2x minus 7.
2x. Is it minus 7? Yeah, it is, I think. Because this would be negative 3 minus 4. What do you have to do there? Keep change, you get negative 7. You are correct. Nice job. Nice job. Careful, keep change. That will get you. Okay? Be careful. That's why it's important to write it out if you need to write it out. Sometimes you can't see it. One thing I want to talk about is if they pull out the distributed property, because we did this yesterday, they're combined what we did yesterday with today. Now, it's not difficult if you've been paying attention. First thing, what do you think you need to do? If you're given a problem like this, what's the first thing you think you need to do, McKenna? Sure, one with the Y. I like it. What's the next step you think you need to do, Logan? Yep, number one thing you have to do is distribute. That's the first thing. You cannot combine things until you distribute. Okay, so how do we do that again? Remember, just like this. So 6y plus 48 minus 5y. I'm going to write that a little nicer. I don't really like. Okay. Distribute the property first, then you can combine. Then you can do your combining. Yep.
You solve it?
Yep, so well, as far as you can. So I can do these things, right? 6 minus 5, I get 1y plus 48. This is what I want as an answer then. Yep. So first you're distributing, which we did here, then you're solving, you're combining as far as you can. Do that. All right, do this by yourself. Do that one by yourself in your notebook. When you're done, talk about it with your partner. You will have some ones in your homework that you have to distribute with. I think I even have to switch this because I'm not going to have time. I'm going to change the homework assignment. So I hope you didn't write it down. I think we're going to have to come back tomorrow and talk about this again. Eventually. Actually, I'm probably going to do this again tomorrow, because you need to know how to do it. So how about 2 through 12? Evens. 16 through 32 evens. All right, anybody want to try? Anybody want to try? Logan, let's hear it.
10x minus 14.
Okay, so first you did this, right? 7x minus 10 plus 3x. Oh, wait, minus 14, I'm sorry. Minus 14. So you would have had 7 plus 6, 10x, not 7. Yeah, I don't know why I did that. Minus 14, yep. There you go. Nice work. Tomorrow, I'm going to come back and work on this again because there are story problems to this, and I want you guys to see how the story problems are set up, okay? Because a lot of times I have kids that get confused with the story problems. So I'm probably going to do this again tomorrow. We're going to practice this again tomorrow because it's an important thing we need to know. Do you have homework? Yes. I'm still going to say again, yes. So don't think that because we're going to begin tomorrow doesn't mean you don't have homework. So I changed it a little bit up here because I took the story problems out to talk about them tomorrow. So I changed it to 2 through 12 evens. And then 16 through 32 evens on page, starting on page 301. Now, I need to talk about the directions with you because there's specific things they want, and I don't want you to do too much work. Because some of you will do too much work because you're reading directions. So get it written down and go back to your desk because I want to talk about the directions.